Look at the part of the review for the second test, the second 6 weeks pre-cal, where we're talking about the rational root theorem, Descartes' rule of signs, and synthetic division in solving any polynomial. So if I'm looking at number 1, first thing that I want to do is I want to use the rational root theorem to find all the roots. And so we got A, we want to use Descartes' rule of signs to find the number of positive and negative real roots. B, we want to find roots using the rational root theorem, P over Q. So let's just start with finding my P over Q. P is 1. No need to put negative 1 because we're going to take care of the negative when we look at the factors of P. The factors of P are plus or minus 1. Q is 1. Now remember, P is the constant and Q is the leading coefficient, or the number in front of the highest powered variable. So Q is 1 and the factors of Q is plus or minus 1. P over Q is plus or minus 1 over plus or minus 1, which is simply plus or minus 1. Which makes life a little bit easier if you've done your homework. Probably didn't have any homework problems with so few P over Q's. Next thing I want to do is Descartes' rule of signs, which is where I'm going to look at the sign changes to determine how many positive and negative roots that I have. So the first thing that I do when using Descartes' rule of signs is look at the sign changes of the function you're given. Here I'm going from a positive to a negative, so that's 1 sign change. Negative to a positive, that's 2. Positive to a negative, that's 3. So I have 3 sign changes. That means I have 3 or 1 possible positive roots. Because remember, I count down by 2's. So if I had 3 sign changes, I go 3, count down by 2, I get 1. So I have 3 or 1 possible positive roots. Now finding possible negative roots, I'm going to have to erase some of this. So you already know this is there. You know that P over Q is plus or minus 1. To find possible negative roots, I have to look at f of negative x, which means I rewrite my function using a set of parentheses everywhere that I have an x. And I want to plug in negative x inside those parentheses. And simplify. A negative number raised to an even power is positive, so that's x to the 4th. A negative number raised to an odd power is negative, but since this 2 is also negative, and negative times a negative is positive, so that's plus 2x to the 3rd. Then positive times a negative is negative, negative 2x, and then minus 1. Now look at my sign changes. Positive to positive, no sign change. Positive to negative, sign change. Negative to negative, no sign change. So I have 1 sign change, which is 1 possible negative root. Okay, so that's Descartes' rule of signs. You will have a couple problems on the test that just ask you to use Descartes' rule of signs. If you can't do that, you're going to miss them. Okay, so B says find the roots using the rational root theorem. What this means is we want to actually start using synthetic division to find these roots. Now recall that P over Q is plus or minus 1. In this case, I know that there's 3 or 1 possible positive roots and 1 possible negative root, real roots that is. That means that in this case, Descartes' rule of signs may not be very beneficial because, in my opinion, Descartes' rule of signs, even though you need to do it for each problem, is only very beneficial when it eliminates one of the positive or negative P over Q's, so that you have less numbers to do synthetic division with. Anyway, so we know that P over Q is plus or minus 1, and so I want to begin my synthetic division with 1. Then I write 1, because 1 goes in front of x to the 4th, then minus 2, because minus 2 is in front of x to the 3rd, X squared is missing, so I put a 0. Then I put a 2 because it's in front of the x, and then minus 1, which is my constant. Bring down the first part, and I begin. Now, quickly before I go on the quiz that we took, a lot of people made the mistake on synthetic division by putting a 0 when you had a missing constant. Okay? We don't have an example today of that because here I have a constant, and over number 2 I have a constant as well. But whenever you have a missing constant, you do not put a 0 there. Okay? All right, continuing to move on. Doing my synthetic division. 1 times 1 is 1. Put the 1 there. Add these together. Negative 2 plus 1 gives me negative 1. 1 times negative 1 is negative 1. Add these two together. I get negative 1. 1 times negative 1 is negative 1. Add these two together. I get 1. 1 times 1 is 1. Add these two together. I get 0. My remainder is 0, which tells me that x equals 1 is a root. Since I found that x equals 1 is a root, I want to check to see if it is a double root. Whenever you find a root, you always want to check to see if it's double. So I take what I have left, which is now a cubic, by the way, because I started with a quartic. So this is a cubic, and I want to divide this by 1 as well, checking to see if 1 might be a double root. 1 times 1 is 1. Add these together, I get 0. 1 times 0 is 0. Add these together, I get negative 1. 1 times negative 1 is negative 1. Add these together, I get 0. That tells me that 1 is a double root. Since I started with the quartic, this was a quartic. When I divided out a root successfully, this became a cubic. And what I have left here is a quadratic. I have x squared plus 0x minus 1, or simply x squared minus 1 equals 0. And I can either factor or use a quadratic formula to solve for my final two solutions. Remember, when you get down to an x squared, you always want to factor or use a quadratic formula to find your final two solutions. So what I have here, this factors, this is the difference of squares. I have x plus 1 times x minus 1 equals 0. You set each factor equal to 0 and solve for x. And we get that x is equal to negative 1 and positive 1. So I have my final two solutions go here as positive 1 and negative 1. And it says to write the zeros in factored form. How do you write it in factored form? You simply change the sign from your factors here, or your zeros. You have x minus 1, x minus 1, x minus 1, and x plus 1, which simplifies to x minus 1 cubed and then x plus 1. This is my factored form. Now, using a complete sentence for pre-AP students, if I ask you to use a complete sentence on a test, you need to give me a capital letter at the beginning and punctuation at the end. Use a complete sentence, tell the number of roots. Well, I have 4 solutions, so I have 4 roots. It says, and describe the roots. Are they real, imaginary? Well, it's 1 is a triple root here. I know this because there are 3 of them. There are no imaginary roots. They're all real roots. And that's number 1. Let's move on to number 2. All right. Number 2. P is 8. Q is, let me start over here. P is 8. Q is 1. Factors of P is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, because these are all the numbers, positive and negative, that go into 8 evenly. Q, the factors of Q are plus or minus 1, and when the factors of Q are plus or minus 1, P over Q is just what my P's are, because Q is 1, and anything over 1 is itself. So P over Q, all of my possible roots here, are just what my P's are, my factors of P. Using Descartes' rule of signs, no sign change, no sign change. I have a sign change, so I have one possible positive root. Looking at my possible negative roots, I have to do f of negative x. So I have rewrite my function using a set of parentheses everywhere that I have an x. And plug in my negative x. Negative number to an even power is positive, so that's x to the 4th. Negative number to an odd power is negative, so that makes this a negative 6x cubed. Negative number to an even power is positive, so that's plus 7x squared. Negative times negative is positive, so that's going to be plus 6x and then minus 8. And look at my sign changes here. There's 1, 2, 3. So I have 3 or 1, counting down by 2's, possible negative roots. Okay? So again, Descartes' rule of signs here. It might help out a little bit more since I have all these different factors. If I can find my one positive root from the beginning, I know the rest would be negative. So let's just continue on here with my synthetic division. I'll give myself a little room here. We know that P over Q is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So I'm going to start with 1 and hope I get lucky. So I put a 1 for the coefficient in front of x to the 4th. 6 is in front of x cubed. 7 is in front of x squared. Minus 6 is in front of x. And then minus 8 is my constant. Bring down the first term. 1 times 1 is 1. Add these, I get 7. 1 times 7 is 7. Add these, I get 14. 1 times 14 is 14. Add these, I get 8. 1 times 8 is 8. Add these, I get 0. I got lucky. 1 is a solution. I have one possible positive root. That's going to be the 1. What that tells me is now I can just focus on my negative roots. So I take what's left. 1, 7, 14, 8. I'm going to try negative 1. Bring down this 1. Negative 1 times 1 is negative 1. Add these, I get 6. Negative 1 times 6 is negative 6. Add these, I get 8. Negative 1 times 8 is negative 8. Add these and I get 0. Got lucky again. So my second root is negative 1. Now I'm down to a quadratic. I have x squared plus 6x plus 8 equals 0. I either factor or use a quadratic formula to find this. And I'm getting lucky again because it's factors. Using Mustang factoring, you would see that x plus 4 and x plus 2 equals 0 is the factored form because 4 plus 2 is 6 and 4 times 2 is 8. So to find the actual zeros or roots, I set each one equal to 0 and solve for x, and I get x equals negative 4 and negative 2. So the factored form of this, here's all my solutions done, and I should have 4 because my highest power is 4. Here's all my solutions. The factored form is going to be x minus 1, x plus 1, x plus 4, and x plus 2. This is my factored form. Just change the signs from my actual roots. Now, using a complete sentence to describe these roots, well, looks like they're all single roots. There's no doubles, there's no triples, there's no imaginaries, so they're all single and real because there are no imaginaries. And that's how you would go through all of those steps to do both of those problems, number 1 and number 2. Okay? Continuing on, let's look at the back side of this review. I deleted some of these, so... Okay, we want to find the polynomial function with a leading coefficient of 2. Okay, that's easy enough. That tells me that the number out front, I'm going to have y equals, or f of x equals, and the leading coefficient is 2. Got it. The degree is 3. All this tells me is how many x's I'm going to have. I'm going to have 3 x's. And here are my zeros. So if these are my zeros, how I write these in factored form is just like I just got through doing on the previous examples. X plus 3, x plus 4, and x minus 2. So I'm done. Because I have a polynomial with the degree 3, because I have 3 x's here. The leading coefficient is 2. And here's the thing. It says write in standard form, not in factored form. So how do we do that? We're just going to FOIL it out. So I can distribute the 2 here. That gives me 2x plus 6 times x plus 4 times x minus 2. So I'll start with just FOILing these 2. So first 2 terms together, 2x times x is 2x squared. Then the outside 2 terms, 2x times 4 is plus 8x. Then my inside 2 terms, 6 times x is plus 6x. And then my last 2 terms, 6 times 4 is plus 24, which gives me 2x squared plus 14x plus 24. 14x when I combine the 8x and the 6x. Now I have to multiply this times x minus 2. And some of you may want to do box method or whatever. If you wanted to finish this up with box method, you would need a 2 by 3. And sometimes this is easier when you're dealing with a trinomial. So the trinomial goes across the top. You have a 2x squared here, and you have a 14x here, and the plus 24 here. And across the side we have an x and a minus 2, and then I multiply the appropriate boxes. So I have 2x to the third, then I have 14x squared, then I have 24x, then I have minus 4x squared, then I have minus 28x, then I have plus 48, then I combine all my like terms, and I have 2x to the third. Then these 2 are my x squared terms, and I have a negative 4x squared and a plus 14x squared. So that's plus 10x squared. And those are gone, so I can cancel them. Then I have these 2 are my x terms. I have minus 28x and a plus 24x, which is a minus 4x. Those are gone. And then I have plus 48. So this is actually a minus 48 because negative 2 times 24 is a minus 48, not a positive 48. Just got to do those kind of checks every now and then to make sure that you're paying attention, make sure you're alive out there, not just being totally entertained by these awesome videos. So I've got 2x to the third plus 10x squared minus 4x minus 48 is the actual standard form polynomial, not in factored form, so pay close attention to that and finish that on up. One more example. So it says to use g of x equals x to the fourth plus 3x to the third plus 4x squared minus 2x minus 5. We want to use the remainder theorem and synthetic division to find these values. You should know that the remainder theorem, using the remainder theorem and synthetic division, will produce the same answers. So if I just want to use the remainder theorem here, I have g of 2 is equal to x to the fourth plus 3x to the third plus 4x squared, and this will be a portion of the test where you cannot use a calculator, times minus 2 times x minus 5, and then plug in the 2 and then begin to simplify. 2 to the fourth is 16 plus 2 to the third is 8 times 3 is 24 plus 2 squared is 4 times 4 is 16 minus 2 times 2 is 4 and then minus 5. Continuing on, 16 plus 24 is 40. Bring the rest down. Step by step is good here. 40 plus 16 is 56. Bring the rest down here. And then 56 minus 4 is 52. Minus 5 is 47. So now when I do synthetic division just like this, instead of doing g of 2, I'll take that 2 and put it right here. 1 is in front of x to the fourth, 3 is in front of x to the third, 4 is in front of x squared, minus 2 is in front of x, and my constant is minus 5. When I do this, my remainder should be 47 because that's what I got here. Bring down the 1. 2 times 2 is 2. Add these, you get 5. 2 times 5 is 10. Add these, you get 14. 2 times 14 is 28. Add these, you get 26. 2 times 26 is 52. Add these, you get 47. I'm on the right track. And since b is exactly the same, I'm not going to work that problem. That should be very easy. Hopefully no one misses these two problems on the test.